Howdy tours, welcome back to the Zach Life. So on today's episode, this is a sequel to the one, the other separator video. If you'd like to watch it, there's a link in the description. So I'd like to talk about this separator. In this part of the country, they're known as a gun barrel. It's a pressureless, valveless, gravity only oil, gas, and water separator. It's a three-phase separator. It separates gas, oil, and water without any valves, without any pressure, and only with gravity. It's a pretty cool, ingenious design. So this lease was originally drilled and developed by the Continental Oil Company, or Conoco for short. And the Continental Oil Company, the first two wells they dug were in 1921. They were up on the very corner of this lease, in the very tip corner for some reason. And there was a really good well that's about a half mile or so as a crow flies, and I think they were trying to get close to it. I've always heard stories of it. It was drilled in 1916. It was an extremely good well. I think it come in at probably a couple thousand barrels a day. I don't know exactly any details about it. But anyway, this lease was originally drilled. This drilling started on a corner up here. They drilled about 10 wells. They dug some really good wells, and all this equipment was originally in that corner. In about 1926, the best I can tell, and I don't have exact dates on that. I've got immaculate records on this lease, but some of the inner workings of stuff like that, I don't know. In about 1926, they moved all their equipment from in the corner of the lease to right here in the center, and they built a big powerhouse. It's right behind you. It's right out there through the trees. I don't know if you can read any of this. This says 8 of 38, but the 3 is upside down somehow or another. This separator was built in 1938, which can't make it original because this stuff was here about 10 years before that. It was built during its peak life in the very early years, and so though it's not actually original, I would still consider it to be original, if you know what I mean. Anyway, I'd like to take you up here and walk you around because it's kind of cool, all the stuff they did up here. So all this stuff is original to 1926. It's very obvious that there was a fence that went here, the fence tied to here, and there was, you know, obviously a gate that was hooked on here one way or another. And you would walk into this tank battery system through this gate, and there are sidewalks that go everywhere. There were sidewalks that went around to the back of the tank. You could walk down the front of the tanks here. First 3 tanks here have got a concrete pad made under them. One of the things that amazes me about this oil lease, and oil leases in general, but this one specifically, is it's had so few owners that there hasn't been new people to buy it that want to change things. And so someone buys it, likes how something's set up, and it's just stayed that way for decades. One thing in particular is this header. Now this header has been rebuilt, you know, probably a dozen times, every decade or less. But this is all the flow lines that come from the wells from each direction. You know, there's 3 lines going that way and 2 lines going this way. You can hear all the fluid rolling through this line. This originally would have been piped with hard steel line, and that header originally would have set exactly right here. This is the connection that it would have connected to. It when it went down with a 90 and right into this separator, and it's still oriented the same way. It's just exactly like the old one had originally been. This just had steel lines. Now over the decades, the steel lines have been replaced with the poly lines. And at some point this was picked up and swung over here, but these 3 poly lines are still exactly the right length just to pick this thing, that header up, swing it back around, and plop it right back down where it would go. So anyway, this is the line that would carry the fluid, the oil and gas and the water, up into the separator. So you'll have to bear with me because this is a little bit hard to explain, and I know it's going to be a little bit hard to grasp, and I'm going to probably repeat myself a lot, but I want you to understand how it works because it's really neat. So I think the first thing we need to do is climb up on top of it and look at it from the perspective up there. All right, so if you're wondering why there's radio towers and stuff on top of this thing, the reason is in the early 2000s there was a wireless internet company that came and actually used this as a wireless internet tower. So that's why all this radio equipment's on it. It's not used anymore. But anyway, here we're up on top of it. Here's the line I was describing that's coming up. The fluid comes up, everything mixed in that comes up through this 3-inch line and into here. So inside here is actually a T. So there is this connection and this connection. This is the input to the separator. These are both tied together, and they're tied into probably a 3-inch line that's inside of here that goes down about 2/3 of the way to the bottom. So I'm never going to get this explained in an understandable way without a visual aid, so I drew this up. Maybe this will help. This brown here is representative of the line that I was just talking about. This is the line that comes down around and down the tank, where the oil and gas and water all mixed together, comes up and into here. This side was plugged off, but to represent it, it had a plug on one side and a line on the other. This fluid comes into a 3-inch line, and the 3-inch line comes down inside this larger piece of pipe where the radios were attached at the top, down to about 2/3 of the bottom, specifically lower than this large hole that is cut in this larger diameter pipe here. Now what happens is as the fluid comes into this piece of pipe, this is its initial separation. By dumping this fluid into this pipe and not directly into here, this doesn't allow the oil and gas that's in the main tank or the main separator to be churned up. All the churning happens inside this piece of 12 or 14 or whatever inch size pipe it was. Now the gas and the oil obviously coming out of this will initially start to rise. The water will initially start to fall. You've got a zone here that's still pretty well churned and mixed up, but this is the initial separation phase. Now the oil, when it comes up, will come out through this big hole and into this big tank. The water does the same. The water falls down to the bottom and comes out this hole. Now the gas that comes up, there's probably some that actually does escape through this large hole, but the majority of the gas bubbles straight up through this and up into this top part of this big piece of pipe. Now this light green is representative of gas. The darker green here is representative of oil, and the blue is of course water. Now this would be the gas output of the separator up here at the top. Now there's actually been a collar welded on the top, and the top flange has only got a couple of bolts in it. That's from when the radios were installed. Originally this would have been fully bolted with a gasket, and it's got a either 2 or 3 inch bung welded in here, and this would have been the pipe that would have carried the gas to the powerhouse, to the engine, and to the houses that were around there. Now the pressure is created in this by this is basically like an airlock or a gas lock. So as this piece of pipe fills up with gas, it pushes the fluid level. If this was vented, the oil level would come up to be equal here, but this is like a big gas lock, and the gas pressure pushes the oil down, and the hydrostatic pressure created between this spot and this spot is the pressure output of the gas. So this being 20 foot tall, if you guess this to be 10 feet or 8 feet or whatever, it would give you 3 or 4 or 5 pounds of gas pressure. Of course, this is plenty to supply a home. Usually that's less than a psi, and then of course by pressure regulation, if this was shut off with a valve or whatever, it would simply fill this up with gas, and the gas would bubble out through the hole in this larger piece of pipe and out through the hatch up here that it did not draw. Now how this separator maintained its oil and water level is even more ingenious to me. So this output is the oil leg. This simply, when the oil gets up to this point, it sort of spills out here and runs down to the oil tanks. There's nothing complicated there. It simply ran out that connection, down a steel line, and over to the oil tanks via gravity. It just flowed downhill and ran over into the oil tanks. Of course, it had valves on the oil tanks. You could select which tank you wanted to put it in. This would be where the water actually came out of the separator at the bottom. This has been turned. I actually am the one that took this water leg off of it and junked it. When I pushed it over, it turned this connection. This valve used to point sideways, and this pointed up. But anyway, it had a 3-inch steel line that went up to a spot that was probably about that seam, or maybe a little bit higher. So you had a piece of pipe that came out of the bottom, up the side of the tank, up to a very specific point. This was determined probably by some formula, I'm not exactly sure. I didn't quite finish drawing it, but this would have had a T with a 90 that would have brought out here. So when the water level got up to here, it runs over out to whatever, and it would have a vent that was vented from here over into the separator, and this is to keep this from being able to siphon water. So anyway, this water leg would come up to just a few feet under where we can see there. It would have had a vent that came out the top and was connected through a small 1-inch line to the vent in the top of this, just to equalize the pressure. And then it would have turned and ran out there. Now they used to originally, there was a saltwater pit, and I don't know if you'll be able to see, probably not, but there's some fence posts out there. There used to be a big old giant pit that was out here that they ran the salt water off in. Now, of course, this is illegal now. As they cover the pit in, the salt's kind of dispersed all right there, and it has, the ground's probably not sterilized anymore, but all the topsoil is washed away, so nothing really will grow. Obviously, the most important job for a gun barrel like this is to separate the oil and the water. And to do that, you've got to be able to keep the oil and water contact level roughly in the center of the separator. Now, how this accomplishes that is if you'll pretend that this thing is completely full of water. There's no oil up here. If this is pumped up and filled completely full of water, when the water level gets to the same height as this connection, it will spill over this line here. It will run out of this line. So when there was enough hydrostatic pressure, when there was enough fluid inside to push the water all the way up to that set of connections that were up there, it would simply run over and out. But once the water level gets up to here, this will spill over and carry the water, off elsewhere. Now, as this thing begins filling with oil, the total fluid level, this fluid level here, the oil level, will begin to rise. And the reason for this is because the oil is less dense than water. So when you get this thing half full of oil and half full of water, it takes more total height here to create enough hydrostatic pressure to push the water out this line. I hope that makes sense. This is the cool part about this. As this begins to fill up with oil, the total weight is less dense, so it takes a higher column of oil and water inside the tank to be able to push the water up to this point. Now, at some point, which is determined by where this connection is welded in and the height of this water leg and everything, this slowly increasing total level here of oil will get to this connection here, the output, and as we explained, it simply runs out this and over to the tanks. It's got these little Petcock valves that start up there. There's three sets of sight glasses, and what these are is you could see the level, the oil and water level, the contact point in the separator as you drove by every day. I guess this was probably all originally done with horseback. Even though there was cars in the 30s, there were probably still a lot of horses out here running around. I was talking about running the salt water in the pit, and I know a lot of people kind of freak out, like, man, they run a bunch of that guy's land. Something you got to remember is the guy that owned the minerals and the landowner was the same guy in 1921. And the best I can figure, the land out here in the 30s brought, especially after the stock market crash, brought sometimes as little as $5 an acre. Probably $10 to $15 an acre is more about what it would bring. This being 640 acres, that's, say $10,000 was the top price for the land out here. This is a 7/8 lease, meaning that 1/8 of all the sales of oil go to the mineral owner. And this lease sold about 1 million barrels of oil in its first decade of existence. Maybe 12 or 13 years. The stock market crash slowed it down in 29. But anyway, at the price of about $3 a barrel, that would have been almost $200,000 to $300,000. Conoco paid him in royalties in a decade. Conoco paid him in royalties every year what the whole section of land was worth. So he got to sell the land, 30 times over. Anyway, he didn't care what they did out here. So somehow my closing video from the other day got corrupted and didn't work. So I come back out here and I get to do this again the next morning. So I appreciate you watching. Like, share, subscribe, and all the good things. And catch you on the next one.